Inside just about every single piece of modern electronics you own, your phone, your car, your headphones, there's this tiny, silent workhorse. It's not the main brain, not the one that gets all the glory, but without it, our digital world would literally just fall apart. Today, we're pulling back the curtain on the hidden power of the digital signal processor, or DSP for short.
But first, think about this for a second. Your voice, when you speak, is an analog sound wave, right? It's messy and continuous. The light that hits a camera sensor is also an analog signal. So how in the world does your phone, a machine that only understands ones and zeros, make any sense of it? How does it turn your voice into a phone call or light into a beautiful photo? That is the fundamental problem we need to tackle.
Well, the answer is this incredible process called digital signal processing. The best way to think of it is like a super fast, super smart translation service. It takes all those messy, real-world analog signals and bam! It converts them into clean, precise digital numbers. Then it performs some unbelievably complex math on them and translates them right back into a form we can understand, like the voice you hear on the other end of a call.
Okay, so to handle this constant, high-speed translation, you need a processor. But here's the thing. Not all processors are created equal. This is really a tale of two very different workers. You've got the brilliant, do-it-all generalist, and then you've got the hyper-focused, incredibly efficient specialist.
So, first up, let's talk about the generalist. This is the one you've definitely heard of, the CPU, the central processing unit. It's the famous brain of your computer, and it's an absolute genius. It can run your operating system, load a massive video game, browse the web, and juggle a dozen different apps all at the same time. It is designed for maximum flexibility. And then, on the other hand, you've got our specialist, the digital signal processor. This chip is built for one job and one job only, to crunch those signal processing numbers. Its entire design, its very soul, is streamlined to do this one repetitive, math-heavy job in real time, all while sipping as little power as possible. And when you put them head-to-head on that specific job, well, the performance difference is just staggering. Here we've got a DSP and a CPU, both clocked at the same speed, doing two really common signal processing tasks. An FFT basically analyzes all the different sound frequencies in a signal, and a FIR filter helps clean up noise. I mean, just look at the numbers. The results aren't even in the same ballpark. The DSP is done in a handful of microseconds, while the CPU is almost 10 times slower.
And this chart just makes it crystal clear. On average, a general-purpose CPU is going to take 8 to 10 times longer to do the exact same job as a specialized DSP. It's kind of like asking a world-class chef to go wire a house. Sure, they could probably figure it out eventually, but the electrician who does nothing but that one job all day, every day, they're going to do it faster, better, and way more efficiently.
So how in the world does the DSP achieve this incredible speed? What's its secret weapon? Well, the answer lies in one simple, powerful mathematical trick that a DSP is built to do better than pretty much anything else on the planet.
And what's so fascinating is that all this mind-boggling complexity, filtering the noise out of a phone call, compressing a massive video file, analyzing a medical scan, it all boils down to a huge amount of very simple math, just repeated over and over and over again. It's an operation called multiply accumulate, or MAC for short, and it is exactly what it sounds like. The processor grabs two numbers from a stream of data. It multiplies them together. Then it adds that result to a running total. Then it does it again and again and again. We're talking billions of times every single second. And the reason a DSP is so good at this is because its entire design is just obsessed with the MAC operation. While a CPU might need several steps, several ticks of its internal clock to do one MAC, a DSP has dedicated hardware that does the whole thing in a single clock cycle. It's got these special, uninterrupted pathways to memory for data streams and hardware literally built to loop this one process at blinding speed. Okay, so now we know its secret, this crazy obsession with high-speed multiplication and addition, so let's go on a little hunt for this invisible engine. Because trust me, once you know what you're looking for, you start to realize it's absolutely everywhere.
You know that amazing noise cancellation on your headphones? A DSP is doing the math. Streaming a 4K movie without it buffering every 5 seconds? A DSP is handling that video decompression. Making a crystal clear 5G phone call? Yep, that's a DSP encoding and decoding the signal. They are in medical imaging machines, in the engine control systems of our cars, in our GPS navigators, our Wi-Fi routers. They are truly the invisible gears that make our modern world turn. And this is what these little powerhouses actually look like. They look like any other computer chick, right? On the left, that's a Texas Instruments DSP that used to power our old DSL modems. On the right, a super versatile processor from Analog Devices. They just hide in plain sight, these unassuming little squares of silicon doing some of the heaviest lifting inside our favorite tech.
But just like you wouldn't use the same exact wrench for every single bolt, engineers don't use the same DSP for every job. It turns out there are different flavors of these specialists, and the choice almost always comes down to a classic engineering trade-off. How much precision do you really need for the job? This choice really breaks down into two main types. First, you've got your fixed-point DSPs. These are the workhorses. You can think of them as using whole numbers and simple fractions. They're super fast, cheap, and really power efficient. For most consumer gadgets, their precision is good enough. Then you've got floating-point DSPs. These guys handle complex decimals with extreme accuracy, which makes them a bit slower and pricier. You'll find these in critical applications, like high-end audio or medical imaging, where every single decimal point really counts.
So, after this whole deep dive, what's the big takeaway here? What have we learned? Well, we finally met the unsung hero working tirelessly inside all of our favorite gadgets.
It all comes back to that core idea, doesn't it? The CPU, it's the brilliant manager, juggling 1,000 different tasks with incredible versatility. But the DSP? The DSP is the hyper-efficient specialist on the digital assembly line, performing one critical task with just unmatched speed and efficiency. And you absolutely need both of them to build the complex, amazing devices we rely on every single day.
So the next time you slip on a pair of noise-canceling headphones and the world just melts away into a crystal-clear song, or you make a video call to someone on the other side of the planet, just for a second, remember that unsung hero inside. Remember that specialized little processor performing billions of calculations every second, tirelessly connecting our messy, beautiful analog world to the digital one.